Hey everyone, sorry to keep you waiting. As always, we have technical difficulties with OBS and all that good stuff. I'm just going to share this link and we'll get going in a moment. Mirab, Jacob's not joining today. He's busy with Hyperverse related things, and so it'll be just me. I'm sending out a tweet and then we'll just get right at it. All right, so links have been shared. We are now live, and I'm wondering if the stream is fine. It says that, hey 27VCJ, hey Brainchild and BZ. Really nice to have you. It's been a few days since the last one, and we sort of changed it up a little bit, where instead of doing it Monday, Tuesday, Thursday, and Friday, we're going to do it Monday and Friday, with Wednesday left over for office hours. But yeah, maybe with fewer things going on, you'll be able to attend these things better. So what's going on today, right? Well, we want to make our app, this Hopium thing that we're building, a little more polished, right? And for those that are just joining us, I want to be able to share the link. So here's the link on YouTube for the repo that we're working on. This is the repository that's not yet fully up to scratch. I haven't pushed everything. A little zoom in, sure thing. 120%, I hope that's fine. But after today, I'll make sure to push all the changes. Yeah, so everyone can see it live. All right, let's put up another screen. And let's move over our VS Code editor. Okay, so here's what's happening. We have, okay, I'll bump it up a little bit. So what do we have here? I'm trying to organize things a little bit. Last time it was just the entry point where we sort of log in with FCL, authenticate and unauthenticate, and we can kind of see it here. You know, this button brings up the Blockdo wallet, and we can go ahead and sign in. I've previously signed in with my Decentology email, and now we're in the logged in state, which renders a page for a given user. So we pass in the user as a prop, and let's look at page. What's going on there? So page right now has a bunch of stuff, And what I really wanted to do today was dig deeper into how we can make this a nice interface, right? Last time we spoke about how important it is to let the users know that things are going on. This is the blockchain, right? It takes longer for things to happen because they're on a distributed chain. So we need to inform them of that process. And we did certain things when minting our NFT collection, but we want to make it like actually nice. Okay, so what I'm using for this is this Bulma CSS collection. It's got a user interface framework, and it's very light, and you can compose all kinds of user interfaces from it. It's kind of like Bootstrap but evolved, right? So what I have here is a simple title, a subtitle, which is the currently logged in account, and then we began our developer hours, specifically this repository, by building a widget with which we can send some flow around, right? So let's go ahead and test this new and improved interface. So what I'll do is that Dragon Ball Z Bulma? It's probably inspired by Dragon Ball Z, but who's to say, right? And we have to ask the authors of the framework. So I want to get a Flow testnet account address that I'm going to interact with for now. So someone please share their Flow account address, whatever platform you're on, YouTube, Slack, or Twitter. Just send me your testnet account. And we'll continue. Okay, who's first? I promise to send some testnet flow. All right, that's always good. So we're waiting for someone to give me an address. We have at least a few people watching, so someone should grab their testnet account. We got time. All right, Mayrab always coming through with the good stuff. So this is the recipient, and do we have it in the list? No, we don't. It's a good thing that he shared it with us. So let's send one flow, right? Now, what happens when we click send is very important to the user experience, so that's why we should pay attention to the screen right now. So I'll click send. This turns into a loading indicator. Then we have this signature request from Blockdo, which we can approve. And while it's processing, it gives us a transaction ID, which we can then monitor for changes and let the user know, hey, this transaction is executed, and it's waiting for it to be sealed, and then that's it. The loading indicator is gone, and we've sent some flow to this account. We can actually double check that if we open up the account on Flow View Source. Oh wow, a bunch of contracts here. Okay, so we have 1094. Let's send one more just to double check. And we'll get a new transaction ID. It'll transition over from state 0 to 1. Now it's got this pending state, and it's executed. Take care, BZ. We'll catch you later. All right, and now it's sealed. So it was 94, now it's 95 flow in here. Okay, so the basic premise is we might be overdoing it, but it's good to let the user know what's going on and that they should continue waiting, or at least if they're not waiting around, that the app is handling it. Yeah, so we have this little tiny widget, and if you look at the source code, all it is this sender component, this React component. Okay, And that's quite handy. Whereas previously we had, you know, this block right here, and it sort of shared a lot of code with other stuff. It shared the recipient's address. And now it's sort of this nice abstract component. And so what I want to do right now is I want to clean this up so that we only have things that we're actually going to use. All right. So we have this mint and nifty, and then the send nifty blocks. Okay. So we might as well create new components for those. There's this components folder. Let's open that up, and this is going to be, let's see here. This is going to be the nifty. First is the mint. All right, so minter. Okay, so minter component, and let's open up sender. So then we have these side by side. All right, so what's the start? What's the basic premise here? We're going to use a little, so importing React to begin with, and we're going to form the baseline for this minter component. It's going to get some props, and it's going to return a simple card layout, just like we have right here. So we're just going to build the draft. Okay, so that's that, and we're just going to mark that this is the minter. Okay, export default and minter, and we can start importing it inside of our app. So we import sender. Let's import minter from our components list, and at that point we can go ahead and include it. Okay, so now we have this card right here, and I wonder if we can space them out more neatly. Class block. I guess not. Let's see here. Let's add some margin down at the bottom. Okay, so we got this is a little bit spacing now. All right, so we have this this card here for the minter, and the minter is going to take in it's going to take in a couple of arguments, right? And the first one is going to be the name, right? If we were to open up our cadence and our nifty contract, right here we have an ID and a name. So our NFT is composed of two values right here, and the first one is a numeric ID, and the second one is a string. All right, so we need a couple of fields and a submit button. So we can go ahead and grab all of that. All right, so first is the field for the name. Okay, so this is a little bit of a Bulma walkthrough as well. So if you guys want to build a full stack capability, feel free to follow. All right, so we have an input, and we're going to add some attributes. First one is that it's an input. Then, the second one is the type. The type is going to be text. Then a placeholder, NFT name, or just let's use name. It's going to be simpler. And then we're going to skip on the value. We'll hook this up a little later. Okay, so we have one field for the name, and then let's add another field for the recipient. Now we have this already in here pretty much verbatim, so we're just going to copy that. And we also want to add this button. Okay, so it's going to say mint instead of send. So we're just going to rename a bunch of stuff. On mint, we need to, so every function that's in here or any kind of value that's in here, we need to declare those for this to actually work. So we have this on mint. Then we have a recipient change function. It's going to have an event, and we're also going to have the name change. Okay. So both of these we can start adding. So on change, I'm going to do that, and we might as well provide the value. Hardik, hey Hardik, thanks for joining me for the Flow Developer Hours, twice a week now, Mondays and Fridays. So this is going to be state and name. All right, so this state thing, right? What's that all about? Well, previously we sort of relied on using state, and that's all good. React is really capable. You can do a whole bunch of stuff with use state, but when the state grows in size and there's interdependent values, and at that point you should consider using a reducer. And a reducer is just a simple way to update things in sequence, making sure that whatever sequence you provide to your reducer, it will apply those changes in the same sequence. Okay, so we're just going to use the reducer hook, and the reducer hook requires a reducer function. So we're going to declare a reducer, and now that function is nothing like really too special. Does Bulma require some dependencies to run? I'm glad you asked, Mayrab. The only thing that I'm doing is I'm literally including this link, which points to the CDN minified version of Bulma. So this is a CSS framework. You can just drop it in and works. Okay, so going back to the reducer. What's that all about? The reducer is a function that takes in the current state and an action. Now the purpose of this is to take in the action, and depending on what's in the action, we create the next version of our state. Okay, so a little bit of a primer on React. So we're going to do a switch, and depending on the action type, we're going to do something. Okay, now the default switch is going to just return the existing state without any kind of mutations. All right, so we have declared a basic version of our reducer. Now we can go ahead and use it. Not much we can do with it, but we can use it. So use reducer, provide in the reducer and a initial state. Initial state is going to have a name, that's null, a recipient, that's null, and that's it. So we have state defined, and we have this dispatch thing. Now dispatch is how we submit actions, and React behind the scenes goes ahead and takes those actions, and an action is just really an object. The code is cool and all, but it was, not sure. It seemed like I'm talking to myself. Who's behind the Decentology account? Go ahead and put yourselves forward. I'm looking for a name. All right. So dispatch is just a way for React to take in some actions and then process them, change the state, and update your user interface. So at this point, we have our state, we have our reducer working on it, and our values sort of are lined up. All right, class names is not defined. Okay. let's import something. I missed it. So class names, we import from class names. This is another kind of useful npm module. So class names npm. I end up using this whenever I'm like, some state defines how my component will look like, and whether that state is true or false oftentimes defines if I apply a class to a component. So it's got this nice interface where I feed in an object where the key is the name of the class, the CSS class, and then the values either true or false. If it's false, then the list of class names will omit that class name, and if it's true, then that class name is going to be included. So it's just a nice way to compose your class list. And this is where I'm using it. You see that in the center component, depending if the state is processing, I apply the isLoading class, and if it's not, then I'm not. So that's the basic component. We have a name, we can't type anything, and a recipient. Now, we couldn't type anything because we haven't implemented these functions right here, or these callbacks. We can go ahead and do that by dispatching. So this is the dispatch function that we got from the use reducer, and we just feed it a type. The type is, the type is going to be whatever we define it to be inside of our reducer, because this is the place where it's listening, right? So in our case, we can say set name, and this is going to be the action type, and we're going to return. Everything else is going to stay the same, so I'm just unwrapping, destructing the previous state, and then overwriting values that are afterwards. All right. So I'm just going to change the name, action. Now it's commonplace to have two attributes or two keys inside of your action: name, type, and then the payload. And the payload is going to be the next name. All right. So I'm going to use set name, it's just what I defined right there, and we're going to define the payload. And the payload is going to be the event target value. You're gonna see this a lot in React. All right, so let's see if our name change does anything. So we weren't able to type. Now we're able to type, and recipient we can't type still. Should be pretty easy. Let's go ahead and add same kind of logic there. A little copy pasta, not gonna hurt. And we go ahead and define a new action type, set recipient. Okay, now in this case, it's going to set the recipient instead of the name. It's still going to set it from the payload, which is all good. And we're going to use the event target value. All right, so we can type now. That is cool. All right, so what are we missing? Well, we're missing all the FCL stuff, right? We're not communicating with Flow right now. We're just dealing with the component itself. All right, so how do we communicate with Flow? Well, remember we were sending transactions, right? So in this case, inside of our page, we have some stuff in there. So previously when we were hitting on mint, all of this stuff would happen. We get the minter, we get the nifty, we take the recipient and we deposit it with the recipient, okay? Well, let's go ahead and implement this from scratch, because I guess copy pasting is not a lot of fun for people that are watching. So, let's just build it from scratch and see what it actually takes. So first up, and this is critical, always wrap your FCL interactions inside of a try-catch block. These will oftentimes fail, and the failure is going to be, your contract's outdated, you have a typo and that kind of stuff. This is like pretty much guaranteed to fail at some point. So you want to have a try-catch block to just not crash your whole app and still see what went wrong. So we're going to print out the error if it does break, and then we're going to continue if it does not. So inside of our try state or try section of this try catch block, we're going to create an FCL. So we need to import that, I guess. All right, so we're going to import everything from FCL as FCL. Okay, and we also need float types, and float types are useful when we're sending things to and from flow. Okay, so we have FCL, we have float types for a later time, and we're back into this block right here. So we go ahead and do transaction, and we open it up with a template string. So this is like a template string that gets passed on and interpolated with values into this function. This is a fancy way of doing, you're calling this transaction function with a template string, and the values are accessible that you provide. Okay. First step though, let's define the transaction ID, which is going to be the first thing that we receive once we call FCL send. So FCL send is going to be the way the primary interface with Flow for us. We call FCL send with an array, and that array will start with a transaction. Now, whatever that is, we're going to take care of it later. But for now, things to pay attention to is the basic structure here. And the basic structure is we have our cadence code, that's the body of the transaction, and then we have our arguments, okay, that's an array. Then we have our payer. So this is the guy or girl that's going to be paying, and in this case it's going to be me or whoever is logged in. So auth Z right here. Now authorizations is an array of everyone that needs to authorize by signing this transaction. Okay, so in this case it's just me because I'm interacting with the minter that's hosted on my account storage, and I'm just going to feed in the same fcl.authz. So this is a reference to the currently logged in user, fcl.authz, whenever you're feeding in payers or authorizers or proposers for that matter. Missed that one. So proposer is going to be the account that will increment their proposal ID or proposal key. And this is important so that we're not double sending these transactions by accident. Okay, and then we just limit the gas to the max, I believe, which is 9,999. Okay, and at that point, we, so this is a promise, right? And JavaScript promises have this .then function, right? And using .then, you can take in the result, and then you can process that somehow. FCL has this decode thing, because when you're interacting with Flow has cadence, and cadence has a different type of type system from JavaScript, and so you need to map those somehow. And this is a nice helper to map it back to JavaScript. Okay. So at that point, we're sort of good. We have a transaction ID, but we don't have anything in our transaction body. Well, that's something that we're going to do right now. Previously, what we did was we were importing Nifty right here from a hard-coded account address. Okay, that's cool, but there's a better way to do it if you don't want to hard-code your stuff. So here's a suggestion. We have this FCL config where we set up the access node, which just means that we're working with the testnet, and then we're using FCL discovery to find the wallet. We can go ahead and put anything else in there for our convenience. And in this case, I'm going to put this account, which is hosting the Nifty contract. And I'm just going to say 0x Nifty. So whenever I want to reference the account I'm working with, the account that has the Nifty contract, I can go ahead and use 0x Nifty. Okay, so now this reads like import Nifty from 0x Nifty, instead of trying to make sure like, oh, like, is this the testnet account? You know, that kind of thing. So it's really helpful. I suggest you do that. Okay, so we'll go back to Mint right here. Okay, so now we imported the Nifty contract. We can start interacting with it. And we interact with it by opening up this transaction body. And we're going to use two arguments. The first one is name, which is the name for our NFT, and the second one is the receiver. So I'm just going to use name string, and then the recipient. Let's do recipient, recipient address. Angel Hack. I heard his name this morning. So Angel Hack. Where's Justin? I thought Justin would be with us, but I'm happy to have anyone. So yeah, so that's going to be an address. So addresses on Cadence have different, have a specific type allocated for them. Now what do we do here? Well, we take Minter and we load that from the, there's two sections. First one is the prepare, and there's also an execute. But depending on the structure of your transaction, both of these could be optional. You can have one, you can have both, you can have, you know, prepare or just execute. So it all depends on what your needs are for the transaction. In this specific case, we need one authorized account. So instead of this prepare thing, we list out the accounts that have authorized, and all of those will have the auth account type. And at that point, we go ahead and take in the Minter resource from our storage. So we go ahead and load it from this account. The type is going to be a resource that's nifty.minter, and we load it from /storage/nifty-minter. Okay. All right. So then we go ahead and create or mint a Nifty. So minter.mint, and then we feed in the name. All right. So at that point, we've sort of completed the minting process. We should save our Minter into storage. So to storage/nifty-minter. There's tons of ways of doing this, but I'm sort of replicating what we had before. All right, so then we go ahead and grab our recipient, and we don't need an authorized thing, and we've discussed this in previous developer hours. So we can go ahead and use the get account, which allows us to get all the public information and functionality. So the critical functionality for us is the get capability, and we're going to get the public Nifty collection capability. All right, and we're going to borrow, and when borrowing a capability, we get a reference. Okay, so we transform what's in storage into a Cadence reference. So for that, we need to provide a specific type, and this is going to be any type that implements the Nifty receiver interface. Okay, and then we kind of want to close off the thing if we don't have a recipient. We're just going to drop the whole thing. No recipient found. Okay. And if the recipient was found and their collection is available, well, we just go and deposit the Nifty using this little Nifty syntax right here. So at that point, we have a transaction ID, and what we should do is we should dispatch a specific type of action. And payload is going to be the transaction ID, and this is going to be, let me think, this is going to be something that we, let's see here. All right, so we're going to set the transaction ID, and we're going to use the same kind of interface as before with the sender, where we transaction ID is action.payload. Okay, so here we set this to null. That should be good. Okay, so that's null. We'll go ahead and set it, and we want to make this into a callback. Now, callbacks are good when we have these long-running functions, so that we don't recreate them with every render. So React provides this nice capability where if anything changes in this dependency array, it will only then recreate this function. All right, so I just remember we need to send the name and the recipient address. Okay, so the name is going to be a string, and we're going to build that using fcl.arg. So fcl.arg takes in, so what are we using? We're using state.name, and then we define the type using float types as a string. And then the second argument is fcl.arg, and it's recipient, and this time it's address. I believe that should do it. And then we set the transaction ID to something. Oh, and let's go ahead and copy this where we start and stop processing things. And the initial value is going to be false. And I want to add this class thing. So using class names where we imported it for this specific occasion, something that is only going to show up if it's true. So if state is processing is true, we're going to show that. And on top of that, I want to show us the widget, the transaction widget, which is something that we have to import from components. But Mintar is a component too, so I guess it's right here. Okay. So let's see here. We need a couple more things. We need to start processing. So here we go. We're going to dispatch an event that's type start processing. Okay. That's all it needs, really. It just needs a type. It doesn't need a payload. And if let's say an error happens, we're going to stop. And okay, so now what do we depend on? Well, we depend on, this is for use callback, and sorry if I'm jumping around a little bit. This function needs to change if state.name or state.recipient changes. All right, so state.recipient, we include that into the dependency array. Okay, let's see if this still renders. All right, we missed an async declaration right here. So this is an asynchronous function, and let's reload. Okay, so it loads up. Okay, so the final thing that's sort of missing is a listener for when the state changes for a transaction. Okay, so we're gonna use an effect for that. All right, and this will depend on one thing. Whenever state.transaction ID changes, and if it's not null, then we're going to listen for whatever is in state.transaction ID. and this is the way we access transactions on FCL. And then we're going to subscribe. Subscribe takes in a single function that provides one argument, which is the message. Now, what do we do with the message? Well, depending on the message status, which can go from 0 to 5. 0 is an unknown state, and then it sort of goes to pending, executing, sealed, and then an error state, which is number 5. So if it's 4 or more, then we're done processing this transaction. We can go ahead and stop processing. So this is just going to inform the user interface that processing is now over and we are good. Okay, so all this work. Let's see if it works. So let's do test 1, and I'm going to be the recipient. And let's open up the, let's open up the console. And hit mint. All right, so now the block though showed up, so that's a good sign. We click approve. So far so good. We have a transaction ID. It's pending. That's nice. It's executed, which means we had no errors in there, and it's sealed. All right. That went surprisingly well. Okay, so now let's grab this transaction ID for future reference, and let's see here. So we minted something, but it's, we don't have a place where we render it. Okay, nothing's being rendered. Well, previously we had we had a collection. Okay, so we had collections were being printed with the account component. And where are they? Fetch collection. So this seems like it's good, but it's not really printing anything. I'm gonna leave this here for reference. This is the transaction ID that created that nifty, or minted that nifty. Cool. So inside of account, we have this nifty's thing. Let's try and log it to see where do we get lost. So it's all null. Okay. So that says that this script that we have for fetching is not producing a desired result. It's returning nil if collection reference is not there. Oh, so nifty collection, lowercase n, I believe. Okay. Now this is better. Instead of null, we have an empty array. Empty array is something, but collection, a ref, get IDs, get name. So result is an empty array, and for every ID that we get, we try and get the name. But it seems like, let's check out our minter component. So we went ahead and minted that and stored it in the nifty collection, which has collection and then nifty's. Okay, so fetch collection is using the same address. I believe it should work. Debugging, isn't that the best? So I'm not getting any comments which I could answer, so I guess I'll just jump back into debugging this thing unless you guys come up with something that I could answer. And let's see here. So we're getting this capability. we're borrowing it. So I have a collection, and I'm sure of that because this prints yes. And yeah, so Nifty collection, if it's nil, then this is going to return false, and if it's not nil, it's going to return true. So that part is fine. I have a collection. Now, get IDs must be returning an empty array. Let's inspect our nifty.cdc. So get IDs. Get IDs returns our keys. Let's see. So what if we return a result, and that's an array of strings? So let's experiment right here. Okay. Get IDs expected string. Oh, got UN64. Yep. IDs are UN64. 64. Okay. So it seems like P17. I'm going to remove all the other stuff that's console logging. Remove that. And this is coming from 174. Okay. And we have some console logs instead of app.js. Okay, so it should be pretty clean. We get a bunch of arrays and some nulls. Well, let's try and mint again, and then recipient's going to be me. See if that does anything. Okay, it's executing. And it's now sealed. There's nothing in that collection. Gosh, that is weird. Let's take a look at this account. So we have this nifty contract. Now obviously I can't look at the storage right here. Interesting. So if this is minting it, and it's minting it from the nifty part, the name is coming through. Let's see what kind of name are we sending when we send it. I'm gonna console log state, and that's gonna be useful. So this is gonna be test2, and I'm gonna be the recipient. So we send the test2, recipient is looking good. So we don't need to go further there. So that looks fine. Let's look at page again, because we didn't change much on mint. So we have nifty minter, then the nifty execute, got nothing, so we don't even need it. Recipient deposit nifty. Name is string, address auth z proposers, FCL decode. You know what? Let's check the good old flow scan. So flow testnet flow scan. What is inside of this transaction that we first used to mint something? Unable to find it. That is peculiar. All right, let's do test 3, and it's going to be the same recipient, and we're going to grab it as soon as we get it. So we approve this transaction. We grab the ID, and we go ahead and search for it. Well, that is bizarre. Testnet.flow scan. Let's look at our transaction. Okay, so what do we do here? We go ahead and grab it. We subscribe for changes. Those changes are coming through, but testnet flow scan is not really cooperating, and it's the same ID. Huh. I'm not familiar with this state personally. So, we're able to interact with FCL, and we're getting these things sort of back, but we don't see NFT appear in our collection, even though we're calling everything correctly. So it's almost as if these are phantom transactions. Have you guys seen anything wrong with the testnet? Because I've been working on it for the past few hours, and it's the first time where I'm encountering a problem. Unable to find this transaction. Huh. But it was sealed. Well, this is kind of a weird way to end today's stream with an inconclusive set of events. But I guess we got to go with the cards that were dealt with. So to review, right? What did we do today? Well, we explored how we can optimize the user experience even further. We prettified the UI a little bit using Bulma, which is a CSS framework. It's a nice thing to try out if you guys are scrambling for UI, and it's always difficult for a programmer to get right. So we used that, and we created these card components where we interact with the blockchain with Flow directly, and we're using FCL send to send transactions, and we kind of let the user know exactly what's going on. So here's a quick demo of me sending some Flow. So I want to send 2 Flow to the recipient. We notified the user that this is in processing. We approve it on block though. We get a transaction ID. We cycle through the changes that are coming in to the status, and we let the user know along the way that what's going on. So it's this sort of collection of components is what you guys need to think about when building your own apps on Flow. When communicating with the user is an important part, right? You don't want to keep the user waiting without any kind of awareness of how far along the wait time they are. And so we did this for Flow, for sending Flow, and we then proceeded to interact with the awesome Nifty contract, and we wanted to implement this mint card as well, which takes in a name, string, and an address, which is going to be the recipient of this mint. And that sort of worked up to the point where we had to check it on the Flow testnet, which we can't for some reason get any kind of info back for the transaction that we just executed. And just a sanity check, we are communicating with the testnet. Yeah, we are using the testnet. So it's not that part. I guess by the time we do the next one, which is Monday, so a nice weekend in between now and then, and we'll have it all sorted out for you guys. Okay, so let me know if you have any questions. This has been sort of a whirlwind of mainly client-related concerns when developing dApps, decentralized apps. So if you guys have any questions, I'm here and I'm waiting, and I'll try my best to answer those. But if nothing comes through, then I guess we'll proceed to the exits and finish the stream. Okay, so I'm not seeing anything coming through from either YouTube or Slack. So I'm going to say thanks to everyone that tuned in. This has been Flow Developer Hours number 10. Next one is going to be Monday, 11 p.m. Singapore time. Please tune into that. We might have Jacob along with me. But yeah, for now, for me, Morgan, and the rest of the team of Decentology, I'm going to say farewell. Happy coding. Have a great weekend, and I'll see you on the next one. Bye-bye now.